If you're sitting a higher tier GCSE Physics paper, you're almost guaranteed to get one of these questions that's worth 5 or 6 marks involving 2 equations. So we've got a situation where we've got a toy airplane and a spring, and we've got some information here. It says there's an extension to the spring of 0.12 meters, gives us the mass of the airplane, gives us spring constant, and asks us to work out the maximum speed. So even though this information doesn't look like it's related, we can look at a couple of equations that can help us. So first of all, there's only 2 equations in the whole equation sheet that have spring constant in them. We're going to use the one that's got the elastic potential energy. So that equation is half times by the spring constant times by the extension squared. Now that might not seem to help us because it doesn't have speed in it, but it's something we can calculate straight away to give us a helping hand to the rest of the answer. So let's put in our values. I've got 0.5 times by the spring constant times by the extension. No conversions to do there. So you just plug those numbers, make sure to square the 0.12 into your calculator, and you will get a value of 0.36 joules. So if all else fails, you've got 2 marks there already. So how can we use this to find the speed? Now there's only one equation in the whole of paper 1 on your equation sheet that has speed in it, and it's the kinetic energy equation. So the idea is if I know the mass, which I do, it tells me out in the question, now the elastic potential energy gets transferred to kinetic energy. So if all that potential energy goes to kinetic energy once the spring stopped extending and the plane is moving through the sky, then what we can do is we can then substitute our value for elastic potential energy instead of kinetic energy. So 0.36 is our new value, equals a half times by the mass, which is 0.020, times by my speed or my velocity, okay, which is still squared. I get marked just for doing that. Next, we've got to figure out how to rearrange it. Please make sure you do a couple of lines for this because you don't want to mess it up. It is quite easy to mess this one up. So I'm going to actually simplify this first. I'm going to say 0.36 equals half times by 0.02. So make my life easier. That's 0.010 times by my velocity squared. It doesn't get you marked, but it helps you figure out what to do next because it might be obvious to get rid of a 0.01. I've got to divide both sides by 0.01 to get rid of it from here and to take it over to this side to get my final calculation. So v squared is equal to 0.36 divided by 0.01 equals 36, and the final stage is because it's squared, we've got to square root it, okay? So therefore v equals the square root of 36, which equals 6 meters per second, which gives me the final mark for the unit.